Hi guys, this is Jeff Paskowitz with Screencast, and today I'll be doing a momentum review, NBA Finals Edition, in order to help you guys for your upcoming final exam. Hopefully, by doing this, I'll be able to help you guys jog your memories of how to do momentum problems, and in particular, impulse problems. So the other night, I was watching the NBA Finals Game 2, and LeBron James had the biggest block I've ever seen in my entire life. I'll show you guys the clip right here. So So you have Tony Parker, here gets the pick and roll, passes off to Thiago Splitter, but bam! LeBron blocks him. This guy has all the momentum in the world, but as you can see, LeBron steps in place and jumps up and stops all of his momentum. This just made me think, how strong is this dude? I mean, we all know he's a tank. He's 200 whatever pounds of muscle, but how much force did he have to apply into that ball in order to stop all this guy's momentum? So I made this sample problem in order for us to find out, and here it is. Thiago Splitter, who weighs 117 kilograms and is traveling horizontally at 6 meters per second, goes up for a dunk. But LeBron James jumps up and applies a force for 0.2 seconds that opposes the motion of Thiago Splitter. Thiago Splitter stops in midair. What is the average force that LeBron applies? So in order to do this problem, we need to know a couple things about momentum. First of all, momentum is usually abbreviated as P. Don't ask why, I have no clue. But impulse is a change in momentum. Usually, momentum is basically a product of mass and velocity. So if you have a system that has quantifiable mass and velocity, it has mass and it's moving in one direction or the other, then it has momentum. In this case, our object that had momentum was Thiago Splitter, and the impulse which is always an outside force that acts to change the momentum of the system. In this case, impulse was LeBron, and the equation for impulse is force exerted by the impulse times the time interval which the force is exerted. So if you go back to this problem, we have LeBron who exerts a force for 0.2 seconds. So in order to solve this problem, we know that in order to stop Thiago Splitter's motion, LeBron must apply an impulse equal to that of Thiago Splitter's momentum. And this makes sense because in order to stop Thiago Splitter, his momentum, there needs to be a force that stops his motion. And in order to find Thiago Splitter's momentum, we simply multiply his mass by his velocity, which is 117 kilograms times 6 meters per second. So his overall momentum is 702 kilograms times meters per second. So what we can do, now that we have his momentum, we can set that equal to the impulse that LeBron, or the outside force that LeBron must apply in order to stop Thiago Splitter. So, as I said before, impulse is the force exerted times the change in time, or the time that the force is exerted. So by looking back at the problem, we know that the force exerted by LeBron was 0.2 seconds. So by plugging it into the equation, doing a little manipulation, we find the overall force that LeBron applies to be 3,510 newtons. That's a ton, but it makes sense because he's a strong man, and yeah, I believed it when I saw it. This is that was like 3,510 newtons. That guy's not a small guy either. LeBron's having none of that. That's why he's the best in the world. Thanks for watching, guys, and good luck on your finals.